This is a simplified view of the collections framework. From this simplified view, we will be looking at iterable collections, list, queue, set, array list, linked list, vector and stack, priority queue, maps, and hash maps. So let's start with iterable. Iterable is an interface. The items in green are all interfaces, and the items in blue are all classes. A class would implement an interface, which is denoted by a broken arrow, and a lower level interface extends a higher level interface. Let's say we have a few objects, and let's say we want to put all of them in a collection. It could be any collection, an array list, a linked list, a stack, whatever we need. One of the most basic abilities that we would want to have is to iterate through the collection. The word iterate means to perform something repeatedly. So if we want to carry out an operation on the objects of our collection, we would want to iterate through them one by one and perform something repeatedly. So let's say our three objects are object 1, object 2, and object 3. We took any three from here. And let's say those objects are animal objects, and we are instantiating new animals for those three different objects. And let's say the input parameters are their name, the number of legs, and where they're located right now. Let's say we want to print out the names of all of these three objects. If these objects are in our collection, then we need to be able to iterate through these objects and print out their names one by one. So we will be printing out their names one by one, and that is something that we're performing repeatedly. It doesn't matter what kind of collection this is. This data can be structured into any kind of structure, but regardless of the type of structure that we put all of our objects in, we would want to do different things on each object one by one. And that is one of the most basic abilities that we want to have. What iterable does is that it allows an object to be used in an enhanced for loop. What do we mean by that? An enhanced for loop is just another type of for loop. It does the same thing, but a little bit differently. Previously, we saw that whenever we wrote a for loop, we had to have an iterator. Usually, we would say something like this, where I is an integer that we use as an iterator. An enhanced for loop is written a bit differently. Let's write an enhanced for loop to print out the names of each of our objects here. Do understand that the collection itself is an object. This collection is an object that stores animal objects. So let's say this object's name is my collection. If we are writing an enhanced for loop for our collection that will print out the names of the objects in it, this is how we would write it. So you see, this is a different way of writing a for loop, and usually we use enhanced for loops whenever we're dealing with collections. This makes it very easy for us to iterate through every object in our collection. So what this is doing is that it's taking an object I. This object I is of animal type. It takes every animal object in my collection one by one. So at first, I is equal to object 1 because object 1 is the first element in my collection. It then comes here and prints out object1.getName, assuming that these animal classes have a getName method. And so it prints out the name of object 1, which is Alex. Then it goes back here and takes the next object in my collection. The next object is, of course, of animal type, and now the value of I is object 2. It comes here and prints object2.getName. And so the next output is Marty. Then it goes back here again and takes the third object in my collection. And it keeps on going until all the objects in my collection have been iterated through, and it will keep on printing all the names. We can use the enhanced for loop for all the structures that we saw in our first tree. You must have noticed that we have two different trees here, and iterable is the root of this first tree. So iterable allows an object to be used in an enhanced for loop for all of these structures in this tree. So this is the first thing that iterable allows us to do. And I hope you understand why it is one of the most basic things that we need if we are working with any collection. We need to be able to iterate through each element inside a collection and perform an operation on them repeatedly, one after the other. Great. This is one thing that Iterable does. Iterable also does a second thing. The second thing is that the iterable interface returns an iterator over the elements in a collection. Now, an iterator is another interface, and this interface has three methods. The three methods are hasNext, next, and remove. Let's understand these by looking at our collection once again. So let's say our collection is ordered, which means that the order of the elements is maintained. So let's say object 1 is the first element, then object 2, then there is object 3, then there is object 4, then there is object 5, and then there is object 6. So let's say this is how we are going, just for the purpose of this example. What an iterator does is that it starts from the beginning, and then it can invoke any of these methods. So let's say we have returned an iterator over the elements of this collection. In that case, the iterator first comes here. Let's say this is where the iterator is right now. Now, if at this moment we call hasNext, it will return the value true. Why? Because there is a next element. A next element exists. As long as a next element exists, from the position of the iterator, hasNext will return true. So right now the iterator is here, and if I ask the iterator to invoke the hasNext method, then it will return true. Let's say the iterator is still here, and I call the next method, which is this method. This will return object 2. Next returns the next object. Great. So these are very simple to understand. What remove does is it removes the last element that the iterator returned. So at first we called the hasNext method, it gave us true. Now we called the next method and it gave us object 2. If we call the remove method, this will remove the last object that was returned by this iterator. The last object that was returned by the iterator, according to what we did right now, is object 2. So it will remove object 2 from the collection, and object 2 will go away. Now, remember that we do not know what this collection is. We are just talking about a generic collection. But if, let's say, this is an array list, then this removal will happen in one way. Whichever way the array list implements the removal. If it is a linked list, then the removal will happen in a different way, because the linked list will require its first element to be now connected to the third element. Since iterator is an interface and iterable is also an interface, when we get to the classes, we'll see that they implement the different methods of iterable, iterator, and other interfaces that they implement in very different ways. So ArrayList will implement the methods of iterable in a different way compared to a linked list. A stack will implement the different methods that it gets from these interfaces in a completely different way. But they have to implement some way of removing an element. They have to implement some way of finding whether or not there is a next element that exists. They have to implement some way in which they can get to the next element and return it. They will all implement these different methods in their own ways, but they will have to provide the implementation code for these methods and all the other methods that they inherit from the interfaces that they implement. So that takes care of iterable. Remember that iterable allows an object to be used in an enhanced for loop, and iterable has the ability to return an iterator over the elements in a collection. These two things, being able to see whether or not we have a next element, being able to get the next element, removing elements, and using all the elements in an enhanced for loop to go through them one by one, all of these are the most basic abilities that we need in order to work with any collection. And since they are the most basic things that we need for any collection, that is why iterable is the root of this tree. It's at the very top. So I hope you understand the methods that are there in the iterable interface and why they are necessary for a collection. Now we'll move on to the collection interface and see what that does.